Hi guys, Vitra Mina Tsembiso Mike Mnisi, and I'll be taking you guys through the variability in hypothesis testing, which is on those who are attending at Rhodes, it's page 128 of the module, and to our friends from other universities, you're going to have to listen carefully. It's exercise 7.5, so the question read as, according to many investment counselors, foreign stocks have the potential for a high yield, but the variability in their dividends may be greater than what is typically for local companies. According to one's broker report, the standard deviation of dividends earned by local industry stock is roughly 3%. If the standard deviation of the dividends earned by a random sample of 14 foreign stocks is 5.6%, can we conclude at 5% level of significance that foreign stocks are in general more volatile? So what we're checking here, they're saying that the investment counselors are claiming that the foreign stock is actually much more greater than what the local companies are getting. So we're going to test that with hypothesis testing for variability. So our first step on our step one is our hypothesis, where if you paid enough attention, the data is clearly given. We know that H naught is given, and since it's variance, we're going to square this, but we are given standard deviation, so we're going to have to square that, which is going to be 3 squared, and it's going to be 9. And then our alternative is going to be, since they said it's more than, we also know that it's going to be one-sided. So this is our step one. And our step two, we are going to do test statistic. Excuse my handwriting. Test statistic where we're going to use the chi, right? So the chi here is n minus 1 as squared the standard deviation at the now of the sigma that we are given, right? So remember that this number here that you're given is the same as chi squared at now, and so is this one, right? And then we square it. So the third step that we have is our rejection region. So one thing that you need to remember before we go any further is that chi, right? Chi is always positive. We're dealing with positive numbers. So on chi, we're dealing with anything from 0 going to this direction. So it would actually make sense when you look at our alternative. It's already corresponding with the theory behind the distribution itself. So our step 4, our step 3, sorry about that, we're going to be dealing with our rejection region, which is, we're just gonna put bounces where we are able to reject H naught. So if you look here, we're going to observe a number. So this chi here on test statistic is actually just chi observation. It's what we are observing. So our rejection region, which is here, we're gonna reject H naught if what we observed here is indeed greater than our alternative. So we're going to reject if chi observed, which is the test statistic that we're going to use here, is greater than, you remember that we are given n at the beginning of, that's why I said pay enough attention, 14, which was 14, subtract 1, and then we're given our level of significance, which was 5%. So you're going to have 0.05. So this is the same as 13, 0.05. So we're going to go to our chi table and look for this value here. Can we just go to the chi table and look for this value here?
What are your degrees of freedom again?
It's 13.
We have 29.819.
13, 0.05.
Yes. Right? 22.
22.362.
362.
0.362. So if we look carefully on this statement, we say that we're going to reject H0, which is our null hypothesis. Remember, this nullifies this. So if we reject this, we're basically accepting this guy. So we said that we're going to reject H0 if what we observe is greater than this number. So now let's see if we're going to reject or we're going to fail reject by actually observing the value here. So what I'm going to quickly do...
Is that chi with the 14 minus 1 not squared?
Which one?
No, and at your rejection region?
Oh, it's supposed to be
Is
the
it?
other one.
Is it?
So other one.
Which one? This one?
On top?
This one?
Yeah, chi squared.
So basically,
Yeah.
this is chi-squared, sorry. Yeah, the same thing. So basically what you do with step 4, I just call it the same as step 2 because you're just taking your test statistic and actually pinning it against your rejection region and see if it's actually valid or not valid. So what we're going to do is we're just going to apply this formula here. Right? So we're going to say n minus 1, which is already what we found here. It's actually 13 because it's 14 subtract 1. So we're going to say 13. And remember that our standard deviation is given on the data itself. As I was reading the question, it's given as 5.6. So we're going to square it according to the formula. And then remember that at the bottom we have the null for the variance because we're calculating for variability, which was 3 squared, and we're just going to say it's 9. Can somebody punch this and see? What is the value?
Is it over 9 or?
It's 9.
Yeah, it's over 9.
45.297.
45.297. So you remember, just by going to our rejection region, we can see that this number indeed is greater than this number. So it's agreeing that you can just put a little note there that we are actually rejecting H0. Right? So when we go for p-value, remember that p-value is the smallest value of alpha at which we are able to reject H0. So our p-value always has to agree with what we have already decided. If it doesn't, that means you made a mistake. So our p-value is actually the step number 5. So it's going to be the probability of, you remember in the first step we already said it's more than, right? So we're going to observe the chi that it's here, and then we're going to find the new chi so that we can pin it against and see whether the p-value itself is greater or less than the level of significance we're given. So here, you remember that the value that we observed was 45, 45, 297. So this is the value that we observed. And then it's very important to note that when it comes to Z, we are looking for less than values, but when it comes to T, we're looking for greater values. And also on chi, we're looking for greater values. So when you come here, you don't subtract 1, you go to the table as it is. And remember, when you go to the table, this is the same as saying you're looking for chi, but remember that your degrees here is what? Is 13.
Yeah.
So what changes here is that you put this number here. It's the same as looking for 45.297. So you go to the chi table again and look for this value. So can you quickly go to the table and look for this value? Chi 13, 45.297.
The edge on the right.
So what you're going to realize is that it's actually not there. But you will also notice a trend that as you go to the right side, probability decreases. So you're going to take the last value of the probability that you see on the table. So on my table, on table 13, the last value is 29.819. Right? Is that the same value that we have?
Yeah.
So we can see here that the p-value for this number, because there's a bigger number here, so we'll assume that this bigger number has what? Has lower probability. Therefore, we can say that this number, since it's equivalent to p-value, we can say that itself, chi-squared, greater than 45.297 is less than the probability of the last value, which is the probability of chi-squared greater than 29.819. Right, but again, since this is the same as p-value, we can replace it and put p-value is less than, and then here we take the probability of this number. Just hold the number and go to the top. You're going to find its probability, which is 0,005. So just by looking at this, you remember that our alpha was what? What was our alpha? Our level of significance was 5%, right? Which is 0,05. So what I'm going to remind you again when it comes to deciding here, there are statements that says if p-value is less than alpha, we reject h naught. But if p-value is greater than alpha, we fail to reject h naught. So just by looking at this statement, the first statement, we can see that alpha itself, p-value itself is actually smaller than this, right? So we can just put a little conclusion here that we still reject h naught. So going to the last step, which is the conclusion, we are just collecting all the information that we already compiled from the rejection region and this part. So we're going to do the last step together, which is often the fun step. So step 6 is the decision. So you remember on our rejection region, we said that if chi-squared observed is greater than the chi-squared of 13, which is our degrees of freedom, 0,05, we're going to reject this guy, right? So you're just going to change this guy and say, since, it's as easy as that. Since this is what happened, we reject h naught, right? And we go to the p-value. Remember what we said in p-value, that our p-value that we got was 0,005, whereas our alpha is 0,05. And p-value, so normally I put the values to actually make it more comprehensive. And p-value, which was 0,005, is actually less than alpha itself, which was 0,05, right? It actually agrees with this, right? So we conclude that at 5% level of significance, we have what? Since we're actually rejecting h naught, which nullifies, we're actually agreeing with h1. So we're agreeing that at this level of significance, we have enough evidence. We have enough evidence to suggest that indeed, and then you go to the question itself, that indeed the foreign exchange stock, that indeed the foreign stock is actually volatile. And that's it.